We're coming on to the keynote speech. Now, we cannot have the embodied carbon change we need if we don't have a system to back it up. And the system to back it up is going to be the circular economy. And it's such an interesting subject when you start to unpick what it actually means. And Tara touched there on the longer life value in the buildings in Brixton, the development in Brixton, looking at what it might be in the future, using the crystal ball to gaze at what it might be, and then designing so that it can be changed, reassembled, etc., and deconstructed and reconstructed in a really sustainable way. We have with us today an expert on the circular economy, David Cheshire. He's a director at AECOM, and he's a real specialist in the built environment. He's the author of Building Revolutions. That's a Reba Publications book, and that explains how to apply the circular economy to the built environment. He's just published a second edition, which is a handbook to building a circular economy. And this actually features some UK studies and insights. And when I say just published, the ink isn't even dry on this. David has rushed from this book launch, his book launch this morning, to be here with us this afternoon. So we are really hot off the press. What's really fascinating is that this handbook lays out a layered approach to designing buildings. And it means that these buildings aren't just less bad, but they actually give back to the environment and the economy. And this is really, really critical. These buildings, you know, if we start to redesign the entire process, there is so much that comes out in terms of sustainability, but also in terms of social value and economically. So David is going to explain this. This way of thinking is so critical to our built environment future that the hierarchy that David proposes in Building Revolutions is actually referenced in the latest London Plan consultation. And David's also working with the GLA to implement the circular economy statement guidance. And that GLA guidance is I believe, coming out soon. He'll undoubtedly touch on that. So for our keynote speech, when buildings give back, I hand you over now to David Cheshire.
Brilliant, thank you, Pippa. Well, I mean, I have to say, I think it's going to be hard to follow those presentations. They were excellent, so thank you, and great to see stuff happening in a real live practice and a live project. So I think that's brilliant. I mean, the others have spoken a lot about this, but I think what's really important and coming out is that we are just pulling resources from all over the world, and there's massive mining activities that are going on to give us iron ore, to give us bauxite to make aluminium, and to give us copper and all these other materials that we need. And the UN report out last year was saying that 50% of greenhouse gas emissions associated with winning resources and 90% of biodiversity loss is from the same activities, which is incredible figures, particularly when we spent so much time and effort focusing on operational energy use and all that sort of stuff, which we've been working on for the last sort of 20-25 years. And I think even and also sort of resource constraints, that things like the amount of sand that we need as a construction industry to pour the concrete that we need. Is the second most used resource on the planet after water is concrete, which is incredible to think. And actually, although we've got lots of sand in the deserts and stuff, the sand that we need for construction has to be rougher, so we have to use from beaches or from riverbeds where we're getting all this. And there's now sand wars and sand mafia and all sorts of things happening around the world. And then from the other end of the side, of course, we're demolishing, as Andy was saying, we're demolishing buildings at a huge rate. And you know, there's lots of projects around, lots of buildings around that have been here less than 30 years that are now being demolished. And it's such a crude process. It's not about reclaiming resources and trying to get back all that value. It's typically downcycling, where we're just actually trying to just crush and shred everything, and you know, you can see here what a sort of brutal process it is. And we've got all that aggregate there, which will never be used again for structural concrete. It'll be used for road bases or piling mats. It won't be used again. But actually, there is a really interesting solution to some of that, which I'll deal with right at the end of the presentation, which is I'm very excited about. So really, where we're going is towards this circular economy model, which is obviously linked to embodied carbon, which I'll come on to explain a little bit more. But this idea now that we need to be thinking about a hierarchy of uses where we retain, refit, refurbish our existing building stock because of the significantly lower embodied impact, but also the means we're not having to use all those resources and not creating all the waste that we do at the moment. And I think the dial is definitely shifting on that, and the campaign that the Architects Journal and REBA are pushing now is moving us much more in that direction. We even got some BBC News publicity yesterday, the day before, which is amazing. And then those outer layers there that on that diagram are talking about, on my diagram, talking about reclaiming and reusing and remanufacturing bits of the building. And I'll give some examples of that, but we're a long way really from getting that into the mainstream and making that happen, and not helped by the fact that we've designed buildings in such a way that they're all glued together and it's very difficult to get them apart. And then the outer layer is the sort of last resort really, where we're recycling technical materials like metals and plastic, or composting things like wood and fabrics and returning them to the biosphere through composting or through anaerobic digestion. So that's the crux of it. Then on top of that, for the first book I wrote, I've put a series of design principles together, and I'll just touch on a few of those today to explain broadly what that means and how that all works. And then around the outside there is this idea of circular business models, and as some of the other speakers have just hinted at, is this idea that we'll be looking differently at this idea of being consumers and not just digging stuff out of the ground, using it for a while and throwing it away, but actually the potential for us to be maybe actually making arrangements and deals with manufacturers who retain the use and the ownership over things, but we just basically pay for the service that they offer. So they've got these ideas around paying for lighting per use, and more interestingly I think is Mitsubishi lifts now have a service for pay-per-use on lifts, which is something that could well take off on the basis that we still have to, or we already contract with lift manufacturers for operational purposes. And then the last one at the top I think is really critical, which is actually a complete change of mindset and thinking of waste as a resource. And if you look in the natural world, you do not have any waste. There's no such thing as waste in nature. Anything that comes out of as a waste product from one system then becomes a nutrient or a resource for the next system, and that value is kept through that whole process. And I think that's something that the circular economy and we should be aspiring to. And just as designers, if we create something that we haven't thought about the next life of that, whether it's a building, whether it's a product, whether it's a material, then actually we are the destiny for that product is waste. It will become waste at some point. So that's the complete rethink that we really need. And as Pippa mentioned, brilliant news really that the London plan is taking a lead here and has now got circular economy policies as well as whole life carbon policies included in it. We've been working very closely with the GLA on a day-to-day basis to implement those policies, and we review circular economy statements and whole life carbon, and we're also been helping them to tweak the guidance for circular economy, which is already published, by the way, for last year, but to deal with the consultation responses and develop that and move that on. And I think that's making big strides, and which hopefully will be out before the end of the year. And as Pippa says, I was delighted that they asked if they could include my diagram in the London plan. So how does this all fit in terms of embodied carbon? I think this is my attempt at a sort of simple diagram to explain that typically new buildings are around about 1,000 kilowatt hours per meter squared per year, big commercial buildings anyway. And what's been interesting is seeing that now that the operational energy use, the thing that we've been spending all this time and effort looking at, is getting better, not only because we're putting in heat pumps and all this sort of stuff, moving all electric, but also because the grid is decarbonising. And actually, this is the projections for the decarbonisation of the grid, which you can see are steadily levelling out over time, hopefully, if it all goes according to plan. And actually, it means that actually the operational energy use now is dwarfed compared to this embodied carbon emissions. So what's the first thing we can do as well? We can refurbish our buildings, because we roughly half the embodied carbon impacts by even if we just keep the structure and the substructure, the foundations, we are roughly, that's where roughly half the embodied carbon impacts are locked up. And actually, interestingly, of course, if you do a deep refurbishment, you can get really good operational energy performance, almost as good, but not quite as good as a new build. And actually, the old argument was that actually, if you refurbish a building, its operational energy use is going to be much worse than a new build. So at some point, those lines would cross over, and you would say, well, after 10 years, it's worth, or 12 years, or whatever it is, worth us building new. But actually now, with these decarbonised grid and all the new technology, and it's actually better to refurbish, and the embodied carbon emissions are generally very high. And this is, an example. This is a bit of an old case study now, but I love this example because this really, with the story that actually the developer was thinking that they were going to have to level this and demolish all these buildings and build new, but actually the architects and the structural engineers came back and said, no, actually I think we can keep these buildings and turn it into this. And this was Make Architects, and adding a lot more space, creating much lower carbon emissions, but also getting the building to market far quicker than they would have done. So a good year earlier. And this is something I keep hearing from developers now, is that the market is changing so quickly, particularly for commercial buildings, but even residential things are changing. So actually, you want to get things to market as quickly as you can. And if you've got to spend 3 or 4 years, from maybe even 5, from that twinkle in the eye inception through to completion, the whole landscape has changed, as we saw in the last 18 months. Who would have known where we'd be now and sitting at home having these presentations. And I think related to that is the in-fit out is such a huge opportunity for circularity, and a huge volume of resources is used, as Simon was saying at the beginning, that during the life of a building, we're tearing out and putting in a whole load of new resources all the time. And this was really interesting to see a recent case study from British Land, where actually they kept all of the resources and materials in or as much as they can in the building. They remanufacture the furniture using ripe office. They kept even a lot of the building services, and they reckoned that they did a comparison on cost and saying that this is the same cost as actually returning the fit out to a Cat A, raised floors and ceilings systems that they would have done otherwise. But of course, they let it much quicker because they could get it back on the market again and save tons of CO2 in the process. And what I thought was also interesting is they've actually said that they're taking possession and ownership of the ceiling. So they are actually keeping all of that building services and everything within the landlord demise, because what they're saying is it's really difficult to take back the systems that are normally left for the tenants to look after, because the tenants don't necessarily want to look after them. They don't necessarily keep up the warranties, or they haven't got the paperwork and the maintenance and all the rest of it. And saying, don't worry, we'll keep this. Tenants, you just come in, you use the space and enjoy it. You don't have to have your own FM people, you don't have to maintain everything. And of course, that means when that tenant leaves, they can put a new tenant in without having to rip out and change stuff, because they don't have the warranties and they don't know how it's being maintained. So it's really interesting how that circularity story can run through. And I think this is one of the systemic changes I'd love to see, is moving the line of the landlord tenant line much further into the tenant's demise, and helping with operational energy as well, of course, at the same time. And then I think one of the big other topics is really this idea of designing for adaptability, designing for different uses in the future. Very difficult to do because you're trying to gaze into the future where things are. But imagine if we could keep our buildings so much longer. And one thing we're doing now on our projects is one project where we looked at doing scenario modeling. So actually we said, okay, this is the building form at the moment. How easily could this be changed into, let's say, an office or into a hotel in the future? And what was really interesting was to see what we would need to tweak in terms of fire escape distances, or the size of the stairwells, and those sorts, the relatively tweaky things that we could do. We had very good floor to ceiling heights and stuff already, so that really helped. But were there any sort of critical things that actually didn't really change the design fundamentally, but actually just helped to allow that to be adapted to future uses? And I think that's something we increasingly should be thinking about on our designs. And there's loads of other examples of that in my book, and case studies and things. And then the next thing is around design for disassembly, and this is very linked to adaptability, because actually, obviously, if you design out wet trades and you can make things to be taken apart and everything, then how much better you can make, how much more easily you can adapt the building in its life, and then reclaim components at end of life. End of first life, let's say. So this is I just love this, because it's just such a simple example. Again, it's the fit outs, the interiors, because they're so much more fast moving than the externals of the building, which hopefully the structure and the fabric of the building is around for 100 years, but the interiors might be there only for a couple of years before the next tenant or next occupant comes in, or they want to change the kitchens in a resi or whatever. So this is designed by AHMM for the Google, various Google offices around the world, and the idea is that you can reconfigure this very simply. The facilities management team can unbolt this and change it around and create new spaces and systems and within the building, without creating all that waste that you generate when you have to knock down plasterboard walls and smash them apart, create loads of waste, which, by the way, doesn't get recycled. Typically, gypsum plasterboard is too contaminated to waste to use. So it has to go to monofill landfill sites. It has to be specially treated to avoid it being in contact with any organic materials, because it gives off nasty gases. So lots of stuff that people don't know that happens to waste and end of life. And then I think the selecting materials, this last section is really key to the sort of bedrock of the circular economy, so to speak. And there's loads of examples of that, and some of them Tara's already mentioned, which was brilliant to hear those entering the mainstream. Things like K-brick, I think, is a great example of an unfired brick that is a tenth of the embodied carbon impacts, as well as using waste materials. But I particularly love this one, I think, by Biome, who are a relatively new startup, but are now ramping rapidly into full production. It's mycelium insulation. Mycelium is the roots and the tendrils that grow under the ground, associated with fungus and mushrooms and such like. And you can grow this stuff in the factory. You feed it on agricultural waste, so it's basically taking a waste product. And then, incredibly, it has similar, if not better, performance than the PIR/PUR insulations. And what is remarkable is it's actually naturally self-extinguishing, and I would definitely encourage you to see this clip, which on the BBC, where there's a woman taking a blowtorch to the underneath of this sample and trying to melt a chalk ice that's sitting on top of it. For those not in the know, chalk ice is a ice cream coated in chocolate, and actually she lifts it up after she's burning it for a while, and not only has it not melted, but there's not a hint of any residual chocolate on the surface. So incredible. And you think in the UK, we've just got these massive issues with fire and insulation at the moment, and you think, what a great solution. And just as a bonus, and to top it all, which Tara mentioned as well, it sequesters carbon into it. So of course you've got natural products, you can sequester into your buildings. There was a very scary article on the front page of the papers a couple of weeks ago saying that the Amazon rainforest is no longer a sink for carbon. It's now actually releasing carbon dioxide more than it's holding it. And I think in the future, this is where we sort of talk about buildings giving back. Is I think we're going to have to hold the embodied carbon and hold carbon in our buildings and actually sequester it there, and in our cities are going to have to start being part of the biosphere and part of natural systems if we are actually going to survive as a species. And then I think I love this example, so I always pop this one in. But this is raised floor tiles, which come out of office buildings, particularly in their millions, left out. These ones are being left outside, and they're all being warped and contaminated. But actually, there is an organisation in the UK called RMF who are actually acting as a broker, and what they do is they take old raised floor tiles, they will clean them up. They will remanufacture them, they retest them, which they're doing here, and then most importantly, I think, is they re-warranty them. So then you've got a warranty back from a manufacturer that says this product is sound, and they're saying actually the older ones are better because they're more heavily engineered. This means we're diverting a waste stream, which currently is very difficult to recycle. You put these things with their timber composite in the middle, they actually block the jaws of the metal crushing machines, whereas actually if we're reusing them, obviously we're diverting that, and also then we're not needing to have all those raw materials, and they're cheaper than buying new ones. What's not to like? And we've got lots of clients who are really actually doing this now and starting to be really interested in this. And that really sort of picks up on this sort of waste as a resource idea, and the vision, which is Danny Tingley's vision for this, is that actually, our cities are repositories for huge amounts of resource that we've spent all this effort winning and raping the planet effectively in the process. And actually, we've got this big material stock in here. If we can just see a way of unlocking that, we can massively reduce the new resources required, and also reduce the huge volumes of waste that we're having to ship outside of our cities and try and deal with somewhere. And I think part of the key to this is something that these researchers have found or started to do, which they've been mapping the resources at a city level, which I think is amazing. They've got 3 cities they've mapped where they've been saying, well, these are where all the bricks are in Bradford, for example, and the different ages and the different types of bricks. And we say, look, if there's going to be a redevelopment here, let's say these buildings are going to get demolished for whatever reason, then we can say, well, we can reclaim those bricks because they're pre-1920s or whatever, and they're online mortar. Great, we can get those and we can use those for the new development over here. And you could see if we could scale that up to the whole city resource, you could start to see how that would become our new warehouse, if you like, for raw materials, and help to deal with some of the issues around storage and how we keep materials until they're needed. And then this, just as a finale, this is I think this is just an amazing technology. So Root Group in Amsterdam, and I managed to get here and see them just before lockdown, so I was very lucky. And they have found a way to crush old concrete. And what I didn't know is old concrete or concrete has unhydrated cement in there, so it hasn't reacted. Some of the cement hasn't reacted with the water. And actually what this smart crusher does is it actually can separate out the unhydrated cement, capture that. It can also crush down to aggregate sized particles, and they showed me some of the aggregate they were getting out, and sand sized particles. So basically what you've done is just created the 3 ingredients you need to make new concrete, and actually that's what they're doing. So they're making precast elements on site out of old concrete. So fantastic to be finally at a point where maybe we can start to, well, it's happening here, where we can actually take old concrete and create new, and that I think is truly remarkable. They're also working on the idea of actually the hydrated cement. They're looking at ways if they can actually reclaim back that as well and turn it back into unhydrated cement. And if this could be rolled out, and this could work in other countries, this would completely change everything. I mean, you'd be looking at not having to have all that concrete and all that CO2 associated with it, but also all that massive resource use that we need. And what about all the waste that we wouldn't be having in the first place? So finally, we just try to bring that all together into a project we're doing at the moment, which we were lucky enough to be working with as a multidisciplinary team, working with a sale. So we're doing architects who are just brilliant to work with, and we're doing the structural engineering, the sustainability, and the cost and the MEP on this project, and it's really just at a concept level. And the idea is that actually it's got some very stringent targets of less than 300 kilograms CO2 embodied, and very low basic sort of passive house levels of operational performance, and loads of other things. The one that sticks in my mind is 40% reclaimed or regenerative materials, which is a real push. And what we've done is we've built in this whole idea of designing for disassembly with these universal joints. We've built in some ideas around intermediate floors being made out of timber, so that you could actually go from a residential setting to a commercial setting if you wanted to have additional floor to ceiling heights. Looking at bringing in local construction with a company called Building Blocks and others that actually are a local manufacturing remanufacturing site, getting some donor buildings, as we're calling them, from Meridian Water, that can give us all of this timber on the outside, this metalwork on the outside here. And we were thinking about taking the crinkly tin off the outside and reprocessing that, so we could use that as cladding materials, and then an overall a whole kit of parts approach, and then being able to scale that across the whole redevelopment. So that's at a concept stage, but very exciting to see all of these ideas coming together, including the social elements of this, and where we can be looking at local and things. Circular economy is very local. It's actually the ability to change things at a local level, which I think is very powerful. So that's it, really. So that's my second edition of the book, as Pippa mentioned. I just leave with this idea that we've got buildings as materials banks. So actually, if we do this right now, we could be at a point where in the future, future generations are bequeathed with lots of resources that they could use to reconfigure buildings and reclaim our built environment in a much more positive way. That's it. Thank you for your time.